Welcome to 4.5 notes part 2. This one has to do with irrational conjugates theorem that is similar to, well, it'll help us with what we were doing with solving, I think. Let's see. Irrational conjugates theorem basically says that if you have an irrational number as one of the zeros of a polynomial, then its conjugate is a zero also. So if a plus b, if a plus b is a zero, a plus the square root of b is a zero of f, then a minus the square root of b is also a zero. Now, conjugates are like two number. We did this with imaginary numbers, but it does the same thing. Basically, if you multiply conjugates together, the square roots go away. Just like if you multiply conjugates together that are irrational or complex numbers, then the imaginary part goes away. So that means that if 4 plus square root of 5 is a zero of a polynomial, then that automatically means that 4 minus the square root of 5 is also a zero. And I say over here, it's also true for complex roots. So this is for polynomial functions with rational coefficients. So if we have irrational coefficients or imaginary or complex coefficients, then this doesn't apply. But for the ones we're going to be dealing with, it will. So for instance, let's see, we're supposed to find all the zeros of this particular function, polynomial function. So I'm going to go about it a little bit differently than the part 1 notes. I could go through and I could list 1, 2, 3, 4, 6, 12, all the factors of 12 divided by all the factors of 1, and I could try them out and see what works. Another way of looking at this is by graphing it. Now, if you notice in this graph, so for instance, I just said that plus and minus 1, 2, 3, 4, 6, and 12 are the only possible rational zeros, rational roots there are for this function. That means that if I was trying to make that look prettier, if there's something else, then it's not rational. So let's take a look at our graph. On the graph, I see that I've got -4 is one of the zeros. Okay, -4 is on my list. But over here, this number here is somewhere a little between -1 and -2. Well, there are no fractions on here. There's no decimals on here. So that's not a rational number because these are the only possible rational roots. And this one, again, it's not a rational number. That's going to mean it's coming to some kind of crazy square root thing or something like that. So I'm going to use the fact that -4 does work, and it is one of the zeros to kind of make this easier. So let's take -4 and go through and work this out. Now, I probably could have guessed that -4 was an answer because look at 1 to 4, 1 to 4, 3 to 12 is the same as 1 to 4. So I guess I could have done it in a box, but I'm going to do it synthetically since it's more fun. All right, so 1, let's see, that'd be 0 times 0, -12, +12. All right, so it's showing that it is a 0. Now, because this represents x to the third, this represents x squared. So my new equation is x to the third, x squared minus 3 is equal to 0. Okay, well, that explains it, because if I add 3 to both sides and then take the square root, look what we're going to get. We're going to get x is equal to plus and minus the square root of 3. And those are conjugates of one another. 0 plus the square root of 3 and 0 minus the square root of 3. So the reason why I did it this way is because I wanted to show you with the graph that you can find zeros on the graph sometimes, but sometimes you can't figure it out from the graph itself. You'll get some kind of crazy decimal instead of getting an actual real answer that's definitive, like the square root of 3 and negative square root of 3. So that's the first example. Now, the second part of this will say something like this. It will say, write a polynomial function that has these zeros. Well, if I'm going to write that, the first thing I need to realize is that if I have -3 and +1 as zeros, I can write factors for those. But 2 plus the square root of 5, if that's one of my zeros, then 2 minus the square root of 5 is automatically another one of the zeros, because we're going to assume that these have rational coefficients. All right. So here's where this goes and get a little bit messy, but we'll see what happens. If negative 3 is a 0, then that means that x plus 3 is a factor. If 1 is a 0, then x minus 1 is a factor. If this is a if this is a 0, then x minus 2 plus the square root of 5 is a factor. Well, and think about it. I did x minus a negative 3. That's how I got x plus 3. X minus 1. X minus that thing. And I have to do x minus the other thing. Well, I wanted it to be red. 2 minus the square root of 5. All right. So you're probably thinking to yourself, you really don't want to have to multiply this whole mess out, but that's just what we're going to do. Now, the first ones are pretty straightforward. I think that multiplying these two together, most people can do those out however you do your stuff. All right? But the next ones, you might not realize that this is going to be easier than it looks. So for instance, x minus 2 minus the square root of 5 times x minus 2 plus the square root of 5, getting rid of the inner parentheses. You might try to do this in a box. So I'm going to suggest that you set up this box just like so, and pause the video and see if you can get 4 of the boxes to add up to 0. So pause the video and multiply this thing out. Go ahead. All right, so here we have x squared and negative 2x, and positive 4. But you should have gotten x squared of 5 over here and negative x squared of 5 over here. They're going to add up to 0. And in these other two boxes, we get negative 2 square root of 5. And this one is positive 2 square root of 5, since negative times negative. So they add up to 0 also. And the last one, square root of 5 times negative square root of 5 is minus 5. So I have like terms this way and this way, because they're the only things left. So I have x squared plus 2x minus 3 times, and then this thing is x squared minus 4x minus 1. Now, I hope that's what you got. You can multiply those together. Pause the video and see if you can multiply those together. You can use a big box or whatever you're going to do. And let's see if I can get it as well. Let's see. I get x to the 4th, and the last term is going to be positive 3. I know that part. Now let's see. We have negative 4 and positive 2 makes negative 2x to the 3rd. Those are my x to the 3rds. And then x squareds, I'm going to have negative 1 and negative 8. That's negative 9 so far. And negative 3 more makes negative 12x squared. And my x's are going to be negative 2x and positive 12. Negative 2 and positive 12 makes positive 10x. And I hope that's what you got also. So if I was to factor this thing out, or if I was to graph it out, I would have zeros at negative 3 and positive 1, and 2 plus square root of 5, which must be around, I don't know, 4 point something small, and 2 minus the square root of 5, which is a little bit on the other side of 0. It's on the negative side. So writing a polynomial of least degree with rational coefficients will be the question. A polynomial with rational coefficients and the least degree that has these zeros. You just turn those zeros into factors, and there you're off to the races. Okay.